So this is number 85. And the title is Surface Area. And surface area is the total area of all the exterior shapes, so all the outside shapes, on a 3D figure. Total area of all the outside shapes on a 3D figure. That's called the surface area. So from yesterday, when you're counting area, what are you counting? The number of squares, right? So when you're doing surface area, you would count the number of squares that fit all on the outside. So let's say you were trying to find the surface area of this box. So what shapes are there on the outside of this box? Squares mainly, right? Maybe some of them are rectangles, depending on whether the measurements are the same. So you'd have to find the area of the front, whatever that is. So you do base times height for the front, right? And then you do the same thing for the back. And then the same thing for the right side. Find the area of that, which is base times height. Left side, top and bottom. So you do area of the front, area of the back, area of the right side, area of the left side, area of the top, area of the bottom. Add those all up. That's the surface area. Now, if you were making this box, why would you care about the surface area? Why would that be important to you? Yeah.
It tells you how much volume is in something, how much you have to work with to put something in it, or how big it's going to be.
It doesn't tell you how much space there is inside. It doesn't tell you the volume. But a lot of people think that, so I'm glad you said that. Yeah. That's part of it, yes, when you're making the box. Mm-hmm. It's how much cardboard you need, right? Awesome. If you're making the box, the surface area is how much cardboard you're going to need total to form it. So if you've got these big sheets of cardboard, then you'll know how much to cut out to fold up to make this. That's the surface area. Volume is something different. The amount of space inside is a different concept. But surface area is how much space there is on the outside. Good. All right, so that's how you find the surface area of a box. And there might be some other shapes that have triangles in the front and back, or maybe trapezoids on the top. And so that's why we did all those formulas yesterday for trapezoids and triangles, because there might be weird shapes that have those shapes on the outside. But it's just simply find out the area of all the individual shapes and then add them all up. That's the surface area. Okay, then there's also what's called a cylinder, so I want to draw a cylinder for you. A cylinder is a shape that has two circles and then like a can. So that's called a cylinder. And we're going to figure out how to find the surface area of this. This measurement here is called the radius. And this measurement here is called the height of the cylinder. All right, so when you have a cylinder, looks like this. So what kind of shapes are there? Yeah.
the circle.
Two circles, right? There's a circle on the top and the circle on the bottom. So if we're going to find the surface area, we need to include the two circles. It's been a while. Does anybody remember what the area formula is for a circle? That's okay. It's been, oh yeah, go ahead. Pi r squared. Good. So the area of a circle is pi times radius squared. So in this case, we're going to have pi times radius squared for that circle and pi times radius squared for that circle. So a total of 2 pi r squared. All right, so we're trying to figure out the surface area formula for a cylinder. So far we've got 2 pi r squared, because that's for the two circles. The area of the circle on top plus the area on the bottom. Okay, now we have to include, we've got the top and the bottom already. Now we have to include the sides, right? So if you cut it out like this and fold out the sides, what shape do you get? So here's the cylinder before I cut it. Now I cut it along the edge and folded it out. So what shape do I get, Connor? This is a rectangle, right? So if I'm going to find the area of all of this on the cylinder, I'm really just finding the area of a rectangle. And the way you do a rectangle is you do base times height. Okay, so we got to figure out how big this base is. Okay, so watch where this goes. See this base? When I fold this up, where does it go? Where's the base now? It's on the edge, bottom edge, right? So here's where the base is. You see it? And then when I fold it out, it ends up here. So what's that called? Yeah. It's called the circumference of the circle, right? It's around the outer edge of the circle. So it's been a while. Does anybody remember how to find the circumference of a circle? Yeah? That's 2 pi r. So this thing here is 2 pi r and then times the height. All right, so to get the rectangle, you take 2 pi r times the height. And then, so that's the rectangle plus the two circles. So that'll be the total surface area for a cylinder. Okay, then there's another shape called a cone. And I'm just going to tell you what the formula is for this one. We figured out how it works for the cylinder. But for the cone, the surface area is pi r squared plus pi r L. And I need to draw you a picture of a cone so that I can explain what this L is. So a cone looks like this. The radius is here. If you go straight down through the middle of the cone and make a 90, that's called the height. That's the H. And then this measurement on the outer edge of the cone, slanty, that's the L. That's called the slant height. So there's the straight up and down height, and then there's the slant height on a cone. And the L is the one that you use there. Okay, and then the last formula that we're going to write down for today on surface area is the surface area of a sphere. The sphere is the fancy name for it. What is a sphere? It's just a ball. Yeah. Okay, so the surface area of a sphere is 4 pi r squared. Yeah. So apparently Yeah, this is a great question. So I'm not so good at drawing 3D, but here, I'll give it a shot. So you see that circle that would slice through the middle of it? The area of that is pi r squared. And apparently 4 of those would fit on the outside. Now we'd have to do some experiments and like maybe get some wrapping paper and a basketball and cut it out and maybe try to see if that was true. But for now, I'm just telling you. So yeah, I told you where this came from, which is good. It's always good if I tell you where stuff comes from. But I was asking you to just believe me on those two. But it's still a great question to ask. Do you kind of see how it could be maybe 4 of those? Awesome. All right, so that's it for the note card. Let me pass out the hole punch for you. The title of the paper is Surface Area. And we're going to start with number 7. So what kind of a shape is this? It's a cylinder, right? So we're going to have the 2 circles. The area of the 2 circles. The area of 1 circle is pi r squared, right? So in this case, it's pi times 5 squared. So that's the area of 1 of the circles. Then we have to times that by 2, because the cylinder has a circle on the top and a circle on the bottom. And then to get the lateral area, the area on the sides, you do pi times radius, I forgot the 2, sorry, 2 times pi times radius times height. So 5 squared is 25. And then you take 25 times 2, and that gives you 50. So this is 50 pi. And then 5 times 10 is 50. Times 2 is 100. So this is 100 pi. And then you add those, and you get 150 pi. So what would the label be? Just squared.
Or just squared again?
Because we're not finding the amount of space inside this. We're finding the number of squares that would fit on the top and the bottom and all the sides. Is that making sense?
Yeah.
So if we folded everything out, how many of these would fit on the outer parts? So we're still just counting squares. It's still just area. Okay, I'm going to attempt to draw number 8, but I'm terrible at 3D. You can all laugh at me, but don't laugh too much. So I'm trying to draw a pyramid know I didn't do very good. It's supposed to have a square on the bottom. So you see the square on the bottom? And then a triangle coming here, and a triangle there, and a triangle here, and a triangle here. So I kind of already gave it away, but what kind of shapes are on the outside of this figure? A square and 4 triangles, right? So when I'm finding the surface area, I need to find the area of the square and the area of the 4 triangles. So let me give you some measurements here. This is 10 millimeters. This is 10 millimeters. And then I'm going to draw the square, or sorry, the triangle separately. You see that's supposed to be there. It's, well, of course it's 10 on the bottom because that's that. And then that's 12. Okay, so to figure out the surface area, I'm going to start off with the square. How do you find the area of a square?
Base times height.
Base times height, because it's a parallelogram. Awesome. So in this case, it's just 10 times 10. So that's the area of the bottom of the pyramid. Okay, then I've got to include the triangle, right? So what's the formula for the area of a triangle? 1/2 times base times height. So that'll be 1/2 times 10 times 12. See how 10 is the base and 12 is the height? And then how many of those are there? 4 of them, right? You see on the, well, do you see? You can't really see because my picture is terrible, but we got the right side, the left side, the front, and the back, right? So 4 times that, because there's 4 of those triangles. So that comes out to 100 plus 240, I think. So that comes out to 340. Again, I'm terrible at 3D, but I'm trying. That's supposed to be a cone on its side. Are you with me? All right, so how do you find the surface area of a cone? I didn't really explain how, I just gave you the formula, right? So here it is. Surface area is pi r squared plus pi r L. So what's the radius? Yeah. 10, good, because the 20 is the diameter, right? So 20 times 10 squared plus pi times radius times L. And the L is the slanted measurement, so that's 26. So then that comes out to 10 squared is 100, so that's 100 pi. 10 times 26 is 260, so that's 260 pi. So then altogether that's 360 pi. So surface area is a lot like area. We did area yesterday. You just add up all the outside shapes areas to get the total surface area. Oh, there's a bunch of problems you can skip again today. 3A, I know you're upset about this. Don't cry too much though. 3A, 4A, 5, 5.5, 16, and 17. You don't have to do that.